Hi students, welcome to B.TECH app. In this video, I will explain about the EMF equation of a DC generator student. EMF equation of a DC generator. What is the meaning of EMF? EMF is nothing but what? A electromotive force. Electromotive force of a DC generator. Okay. How a EMF can be induced? On which principle it is depend upon? Nothing but what? A Faraday law. According to Faraday electromagnetism, this EMF is induced. As the armature rotates, when armature is rotating, what happens? What type of EMF we are getting? It is nothing but what? A dynamically induced EMF. Dynamically induced EMF. The voltage is generated in the coil. In the case of generator, the EMF is rotation called the generated EMF or armature EMF, and it is generated by letter E suffix G. E suffix G is nothing but what students? Generated EMF. In the case of motor, the EMF of the rotation is known as back EMF, and it is denoted by letter EB. Back EMF EB, whereas generator is EG. This is two differences you have to keep in your mind, right? The expression for a EMF is the same for the both operations, like a motor and as well as the generator. Okay, so here how the relation to derive for EMF equation of a motor or a generator, what things are required here? That is, P is number of poles in a machine. Already magnetism, number of poles should be there. Flux is the magnetic lines of force. Units is Weber. Z is the total number of armature conductors. If you observe, the winding will be there, na? It is n number of turns will be there or not, right? So total number of armature conductors denoted by letter Z. And n is the speed of the armature in revolutions per minute, RPM. One revolution is nothing but what? A speed, and number of parallel paths in armature winding. These are basic things. What are P, phi, Z, N and A? In one revolution, the armature, the flux cut by the conductor given as P into phi. What is the meaning of P? Number of poles. Phi is the flux, right? To rotate for 1 minute, that is time is equal to 60 by N. N is the speed and 6 is the number of seconds. So then average induced EMF can be written in terms of E is equal to P phi by T. P phi by T. This is the third equation. Okay. First equation, second equation, and third equation. Now substitute the value of T here. Then what happens here? P phi by 60 into N, or P phi by N by 60. That is E is equal to phi P N by 60. What is the meaning of P? P is nothing but what? A number of poles. N is the speed. Phi is the flux. And 60 is the time duration. The number of conductors in series of in each parallel path, right? That is already we discussed A, parallel path, Z by A, or we can write this one, phi Zn by 60 into P by A, or if number of parallel paths are that is in terms of wave winding and as lap winding, I will explain later. So when we do some problem, this is very important here. Where N is the speed in revolution per second, that is N is equal to N by 60, and here if we keep that relation here, so induced EMF is depend upon what here? Phi and N, flux and as well as the speed. Okay, so this relation is very important to control the speed of a machine, right? So E is proportional to the phi into N, or omega. Omega is nothing but what? Angular frequency, frequency, that is 2 pi n by 60. Angular velocity or 2 pi n by 60. If substitute that one, then we will get here Eg is equal to phi Zn by 60 into P by A. Phi Zn by 60 into P by A, where A is the number of parallel paths. Number of parallel paths. So here what happens means, we have two different types of windings are there, lap winding and as well as the wave winding. So for that purpose also, if we derive the relations, then it will be somewhat things. See, EB is there. What is the meaning of EB, Nana? EB is nothing but what? A back EMF. Okay, this relation is for a back EMF of a motor, whereas EG is nothing but what here? EG is equal to generated EMF phi Zn by 60 into P by A. P by A, right? So problem may ask or derivation may ask for a EMF equation. EMF equation or problem, right? Now next, types of generators. Very important one here. Types of generators. We have two different types of generators are there. Separately excited and as well as the self-excited, right? Separately excited. Separately means what? It depends upon others. Okay, a machine which excited by the other machine, that we are saying as a separately excited machine. Whereas self-excited means what? Itself, in its the machine creates its own flux. that we can say as a self-excited machine. So normally the generator or a motor, we depend upon the self-excited machines only, self-excited machine. Okay, so again these self-excited machines are depend upon three types. Okay, it may be a motor or it may be a generator. Okay students, right, step by step I am coming here. So self-excited DC generator, device which currents on the field winding is supplied by the generator itself. If self-excited DC generator, the field coils must be connected in parallel with the armature in series, or it may be connected partly with in series with respect of the parallel, right? So self-excited, its own flux can be created and current can be generated itself. That's what we are saying as a self-excited. And these are again divided into three types, that is shunt, series and compound. Other name of shunt is nothing but what? A parallel connection, series connection. And compound nothing but what is a combination of series and as well as the parallel. Compound is nothing but combination of series and as well as the parallel. Okay students, now so this is a shunt wound generator, right? So this is a field winding and this is a armature and this is a load. Okay, so shunt is nothing but parallel I said. So armature in parallel with the shunt field. Okay, armature winding with respect of the shunt field winding across the load, right? So here we are having a, from EG what happens, current is splitting into load current and as well as the field current, right? So armature current is splitting into two current, that is field current and as well as the load current. Okay students, now a very small field current ISH flows through it because the winding is have many turns and the resistance is very high value. So armature winding in parallel with the shunt field winding across the load, right? That is nothing but what? A shunt wound generator, Okay students, now ISH, what is the meaning of ISH? Shunt current. According to Ohm's law, what we have? I is equal to V by R. So V by RSH, RSH is nothing but what? A shunt field resistance. So V by RSH, that is shunt field resistance, and here armature current is equal to IL plus ISH. So this is the basic formula to find for a shunt wound, that is EG, or one more equation, EG is equal to what we can write here? V plus IA into RA. Yes or no? V is the terminal voltage, EG is the generator voltage, right? Across the load, this is the V and this is the EG. So here to find the EG is equal to V plus IA into RA, but IA is equal to what we can write here? IL plus ISH, that also we can substitute here, or directly V is equal to EG minus IA into RA. This is voltage. Now I want to find the brush drop. Brush drop means what? Here this is the brushes. Student, these are the brushes, two brushes are there, and why the brushes? They are used to collect the current. So EG minus IA RA minus 2 into VB. 2 brushes are there. Next, to find the power, you know voltage, you know current, from that you can find the power. Power is equal to EG into IA and power output is equal to V into IL. So this is about the shunt. Normally shunt machines are used where at no load and as well as at full load. Okay, it's a constant speed device, So this is about the shunt wound generator. The next one is series wound generator. Okay, series means what? Your armature is there in series with the field winding. Okay, which field it is? Series field across the load resistance. Then only we can say this is nothing but what? A series wound generator. See, this is the armature and this is the shunt field. How it is? These are in series. Okay, so across the load. So again what happens here? RSC is the series field winding and IA is the armature current, RA is the armature resistance, and here EG is the generated voltage. Now in series field, students, in series what happened? The current will be same or not? Yes, the currents will be same. So series current, load current and armature current are same. Now to write here the terminal voltage relation, V is equal to EG minus IA into RA minus ISC into RSC, right? But here the current values are same na, so V is equal to EG minus IA into RA plus RSC. Okay, same voltage drop, that brush drop also we mentioned here, and power developed and power output. Okay students, so when he asks problem, not only the voltage but also if problem is asked means, then you have to write this. Power developed is Eg into Ia, Gia. Power output is V into IL. Terminal voltage with respect of the load current or armature current. Okay. Now third one is the compound wound generator. Compound I already said, compound is a combination of series winding and as well as the shunt winding connected to a armature across the low resistance. That is nothing but what a compound generator. Again, this compound generator are converted into cumulative compound and as well as the differentially compound. Okay, cumulative means what? The two currents are mixed, that is shunt current and as well as series currents are combined. We are saying as a cumulative compound. If both are differ, then we can say as a differentially compound generators. And a part of this one, the designing also important here. Low shunt and as well as the high shunt. Okay, low shunt connection and as well as the high shunt connection also very important here. Low shunt compound wound generator. See, this is the armature, this is the shunt field and this is the series field. Okay, that's what we are saying as a compound, combination of shunt and series across the armature, across the load here. Okay, same shunt Is is equal to V by RSH and series the currents are same. Okay, if you substitute these values here, okay, Eg minus IaRa minus IaC into RSC, where the current values are same, then power developed and as well as the power output V into IL, Eg into Ia. Now short shunt, see, before we discuss about the long and short shunt. How the short shunt is there? Short shunt is not accurate to the that one. Okay, we can connect it across this armature only. Okay, there is nothing but what a short and long. According to our requirement, we will use such type of connections. Okay students, so these are the some of the connections of a generator. Okay, thank you.